In this video, I'm going to take you through the answer key to the economics question on the Fall 2016 Engineering Business Practices CEE300 midterm. Describe nominal and effective interest rates and the difference between them. The nominal interest rate is expressed as a percent per year without regard to compounding. But the effective interest rate is what you pay when compounding is taken into effect. So the difference between nominal and effective interest is compounding. For example, nominal, which comes from name, is what they might put in an ad when they're advertising a car loan in a newspaper, and they say, pay only 4% per year. But then when they compound that monthly, the effective rate, what you actually pay, is going to be higher. Because at the end of the first month, you'll pay, 4% per year. So the monthly interest rate would be 4 divided by 12 per month. They'll add a little bit of interest onto your balance. And then the month after that, they add interest onto the balance that already contains some interest. And this is the impact of compounding, so that you pay interest on the prior month's interest. The effective rate is always greater than the nominal rate whenever the compounding period is less than 1 year. Write the mathematical equation that describes the discount of a future sum of money to present value, assuming continuously compounded discount rate, and explain each variable. We're going to use F for the future value, P for the present value, and we know when it's continuously compounded, we've got to use E, the universal constant, and in this case, raise it to the negative RT, where R is the discount rate. It's a discount rate rather than an interest rate because we're moving from a future sum of money to the present. If we're moving from present to the future, we'd call it an interest rate. But mathematically, it does the same thing. This could be percentage per unit time. Year is typical, and T is time. It works for any units of time so long as the discount rate is expressed in the same units of time as T. The units of time must cancel out in this exponent. So we could have a discount rate expressed as a percentage per month, and time would have to be in months. Sewer system proposal will cost $300 million, carry 30 million gallons of sewage a day. Proposal calls for the sewage authority to charge a fee of 5 cents. I'm going to change that to per gallon. Operating costs are 2 cents per gallon plus $5 million a month. Draw a cash flow diagram for the first year. Label your axes. A cash flow diagram shows the expenses that we incur and the revenues that we collect. In this case, monthly is a good basis on which to draw our cash flow diagram because these expenses and revenues are shown in relation to time. This cash flow diagram requires costs, so I'm going to draw an arrow down. That's $300 million at the onset of the project. Revenues, we get to collect 5 cents per 300 million, and if you did it as 5 cents per million gallon, that's okay. This is a mistake, but we'll grade it either way. Let me get some math. 1, 2, 3, 50 times 3, 150 million a month. So we're collecting that much. Operating costs, 2 cents times 300 plus 5 million. So that's 60 plus 5 equals 65 million a month in costs. monthly basis for the first year. These are constant throughout the year, so there are 12 of them, but we needn't draw them all the way out. And it looks now like our cash flow diagram is complete. The cash flow diagram only asks for the costs, revenues, and operating costs on a monthly basis for the first year, but presumably these would go on for the entire life of the project. As far as we know, that's infinite, although operating treatment plant, several decades. Estimate the highest interest rate at which the sewer authority could afford to fund the proposal. We can see the difference between the revenues collected at $150 million and the operating costs of $65 million. This difference is the amount that would be available to the sewer authority to pay interest on a loan that they, or a bond or whatever it is, the money that they borrow to build the sewage treatment system. So here is, let me see, 150 minus 65 is a net of $85 million. This is how much they're making every month. And what did they pay? $300 million up front. If we do $85 million a month divided by $300 million, whoops, no units of time on that, then we're going to get a percentage. And there's no reason to do the math, but we're going to get a percentage, dollars over dollars, per month. And that's good estimate of I, the interest rate expressed in terms of percentage per month that of funds that would be available to pay the debt on the $300 million. And it turns out to be quite a lot of money in this example. Another way to do it is to remember the formula P equals A over I. And this is how you discount a perpetual series of regular payments. A sometimes stands for annuity, even though in this case the payments are every month. I is the interest or the discount rate. And this formula is used to discount a perpetual series of payments to their present value. You can see PI equals A. This is the interest rate that you pay, the balance of the amount that you borrow, and thus the interest that would accrue every month or every year or however often you are compounding your interest. So now we've answered all four of the questions. How are they graded? The first one is worth a total of 15% of the total credit on the page. 5% for describing nominal, 5% for describing effective, and 5% for describing the difference between them, which is the compounding period. The next question is worth 20% of the overall credit for the page. And here, you've got to make sure that you both label all of the variables, define each of the variables in the formula, and get them right. So that's 1, 2, 3, 4. 4 different variables to understand and get right at 5% each. Here we have a little bit more complicated problem. We've got to get costs, revenues, operating costs, revenues, operating costs, correct? Have to remember to label the axes, and in this case there's one axis, time. All of these things should be arranged properly, and each one of them adds up a little bit towards your grade. 1, 2, 3, 4 is 4 at 10% each. We're now at 35, 40. That leaves 25% for the last problem. And the last problem you don't actually have to do the calculations because I know you're not allowed to have a calculator on the exam. You need only understand that this is the critically important ratio that allows us to express an interest rate, the maximum amount of interest available to pay on the $300 million debt. The important concept is the synthesis of the whole cash flow diagram into understanding the revenues that will service the debt load. 15, 20, 40 plus 25 is a total of 100% for the page.